Hello, this is the introductory video for GoDutch 1.0. The team members are Jonathan Beltran and Zhenglin. The product owner is Dr. Deng Pan, and the instructors are Masood Sajadi and Mohsen Tahari. The problem that GoDutch wants to solve is that on a group trip, it's very tricky to calculate the final cost distribution among all the participants. It is a boring and time-consuming process, and is fallible. And also, manual calculation will result in a great amount of unnecessary transactions. So the proposed solution of GoDutch is we're going to automate the whole cost distribution process and minimize the total number of transactions among the group. We're going to deliver the solution through a web application to collect the user's purchase and consumption records. To minimize the total number of transactions within the group, we think minimum cost max flow hour could be a good fit. The requirement specification for GoDutch is that since it's a web application, we must have a clean and easy to use UI. We must allow the users to edit the same trip simultaneously and see each other's changes in real time. We also need to have all the calculation happen on the server side to reduce the client weight, and the algorithm must produce the correct result in a fairly short time, even for a large amount of users. In this iteration, we implemented 20 user stories. Here are 4 selected user stories. User story 146. Implement my trip page front-end logic. As a user, I would like to use my trip page to create, view, and edit my trips. For each trip, I want to be able to see all the participants and items purchased for that trip, as well as the relationship among items and participants. The acceptance criteria include my trip page must at least have create, view, and edit trip functionalities. My trip page must highlight the item participant selected by user and highlight related items participants as well. All operations must be done within 0.1 second. The use case for this story is when a GoDutch user wants to edit an item. Here's the use case diagram. The GoDutch user is going to interact with the trip list, where the edit trip button will allow the user to access the trip detail. And the user can also interact with the item detail through the item button. Here's the sequence diagram for user story 146. A GoDutch user go to my trip page and click on the trip item and try to edit the item. After the user finishes editing that item, the page will give the feedback to the user by updating the view. Meanwhile, it will also send saving signals to the backend through socket.io, and the backend will save the user's changes to object storage. Broadcast changes of a trip to all its participants. As a user, I would like to have other people see the updated version of the trip soon after I finish changing it, and vice versa. The new changes should be saved to database and be broadcasted to all users within the same trip. The broadcast should be concurrently saved. The use case for this story will be 2 users are viewing the same trip. One user made changes to an item within a trip, while the other user would see the updated version of the trip soon after the changes were made. This is the sequence diagram. When user on the right edit the item, will issue a save change signal to the routes. So the backend will first of all store the changes into the object storage and will broadcast to all the users with the new change to my trip control in the front end, which will return to the user on the left to show the updated version through the view.
User story number 145 was implement routes using socket.io. The description is, as a developer, I want to handle all my events through sockets. The acceptance criteria was all site functions which worked previously must also function after change, and sessions are now kept track by the sockets. The purpose of this user story was to change our RESTful API routes to use completely socket implementation. We do this because we already use sockets to communicate between the users for everything, so we decided that all the functions should be handled by the sockets. In my use case diagram, I showed I refactored login so that now instead of using cookie-based authentication, it'll use a token-based authentication. When a user tries to log in, if he logs in successfully, the server will return a token to the user. That token will be saved on the client-side browser, and then the token will be submitted again to the server for authentication. If the token is authenticated, the server will send an OK message to the client browser, and the client browser can proceed to the next view. When the client refreshes the page, if the token exists on the client, it will be sent to the server. The server will respond with successful, and then the client will continue to move forward onto wherever he was previously. For user story number 157, implement emailing service, the description is, as a user, I would like to invite my friends and family to my trip via email. The acceptance criteria was that the SMTP service would successfully send emails to any account, and that when a user clicks on that link, they are added to the trip automatically. In the system, the user interacts with a single button. Inside of that button, he inputs the desired email, and he can send the invitation. The actor in this case wants to send an email to his friend, so he puts his email on the button and then he clicks on the button. The socket on the client side will send that email to the server. On the server, we create the user account using that email, and then we create a link which we hash using the email and the date that the link was created, and then we send that email to the user. Once the user gets the email, he clicks on the link, and he now is in the same trip as the original user who invited him.
In our system design for GoDutch, we used both model view model and client-server architectural patterns. As shown in Figure 9, the view model is propagating changes to both view and model, while the view is in the client side and the model is in the server side. The view model communicates with the model through routing services that is implemented using socket.io. Here are the system hardware software resources and deployment diagram. For the development of GoDutch, we used VirtualBox to create different environments, and Google Chrome, which is our target browser, Git Bash that allows Windows to run Linux command lines to ease our development process, RoboMongo to help us visualize MongoDB, and Visual Studio Code that helps developers code and resolve merge conflicts easy and efficiently. For the system deployment diagram, we have GoDutch web server and GoDutch database server hosted on the same machine. However, the web server is hosted on port 8080, while the database server is hosted on 27017. The communication through the web server and user devices, along with GoDutch database server, are through TCP/IP protocols. This is the detailed design for GoDutch. The system design patterns and minimal class diagram. In GoDutch, we use front controller, observer, and singleton design patterns. The routing services serve as the front controller that handle all the user requests. The AngularJS data binding implements the observer design pattern. The singleton design pattern is used to ensure that each user has only one socket communicating with the server. This is the minimal transaction calculation algorithm. We use min cost max flow algorithm for this purpose. Figure 12 shows our max flow algorithm model. There are three layers: the source, users, and the sink. There are links connecting from the source to users that are purchasers, with capacities being the amount of money they spent, while all the users are connected to the sink, with the capacities being the amount of money they should be spending for the trip. Now, all the users are connected to each other as a fully connected graph, which means each user can pay to each other freely. To minimize the amount of transactions among the users, we want to have the dashed lines shown in figure 12 to have high costs. So the main cost max flow algorithm will try to avoid using those edges. After the algorithm is done, we can backtrace the path from the source to the sink to figure out the transactions. Here are the test cases we picked for the stories we explained earlier. The test case for story 146 is to make sure the My Trip page front-end logic works properly. The precondition for this test case is that the My Trip page has been loaded successfully. In this test case, I changed the item name in the item detail panel. After a short moment, I observed the item name in the view change to match my input. Test case 167 is to make sure that users can see changes made by other users in real time. So to test this story, I opened two browsers and log in as two different users that share the same trip. When I use user 1 to modify an item, I observe the corresponding changes on user 2's view in a short moment.
For test case number 145, interaction between Socket.io and AngularJS tests, we were testing for the interaction between the client and the server. The precondition is that the user had just used a function which involved client-server interaction. When a user performed any function on the client side that involved client-server interaction, we did get a response from the server, and we also got the correct response from the server. For test case number 157, sending emails, I put in my email as the person who should receive the email. When I received the email, I clicked on the link, and when I arrived to the page, not only was I inside the trip, I was also registered with the GoDutch account. The technologies we used for this project was NodeMailer, Socket.io, AngularJS, JWT, which stands for JSON Web Tokens, GitHub, Node.js, Express, Bootstrap, and HTML. Our contact info is on the screen. And this has been the introductory video for GoDutch. Thanks for watching.